your check. And I think the gist of it is you understanding these two words today. Congruent and similar, right? In terms of what we've been doing, let's say the transformations, and then let me list them. We did rotations, reflections, what was the other one? Translations, and then we did dilations. Translation and dilation. Now, remember that the first three, and I'll change colors, fall in the category of rigid transformation. All right, what is that? Well, let's see if I can draw it out. Well, I'm not going to draw it out. Let me take this guy over here. No, bad example. Take this guy over here. Okay. I'll make a copy of it. Copy, duplicate. All right, so they are congruent if you can somehow tell me that. Can I move? Let's say this was here and now this is here, right? This is the pre-image. Can you, through rotations, reflection, translations, not dilations, get this rectangle over here that I'm shaking to here? And you're going to say, well, that's easy. Next, translation to the right, however many units, and look, right on top, right? And translation some units now. What if I did this? Oops. Can you somehow use reflections, translations, and rotations and tell me how this shape here, the one I'm shaking, to here? And you're going to say, well, that's easy. Well, from here, first we translate it that way to the right, however many units, and then you're going to say, and then we rotate that 90 degrees counterclockwise. And guess what? Oh, look at that. It fits right on top of each other, and therefore they're congruent. That's what I mean by congruence. Reflection, same thing. Okay. I think reflections is easier if I use a triangle. So here's a triangle. I'm going to duplicate that. And let's say I reflect it off over some horizontal line. And if I did that, let me duplicate this first. Here we go. So if I take that and reflect it, right, over some horizontal line. So, and then I asked you, hey, are these two triangles congruent? Can you prove it? Well, yeah, Mr. Cho, we can. Here's a line, right? And then all you got to do is take this guy here, reflect it, and do they end up right on top of each other? And if they do, they are congruent. Same shape, same size, right? Preserves the shape, the same shape and same size. So congruent, I think you think about same shape, and obviously same size. Now then we talk about dilations. Well, dilations are not rigid transformations, right? So let's take this guy here, and I'm going to put some units. So let's say if why did I delete the other one? Duplicate, so let me duplicate two more. So let's say this guy here, let me make it bigger. I might make that bigger here. No. All right, so I don't know how to make it bigger. I do. I do. No, it's not working. It's not working. Really? All right. Maybe if I just did, oh, there we go. And this one I make it bigger. All right, so dilation was, here's your dilation, and I had the original figure, and let me put some values. Let's make this a 6, and let's make this a 4. Let's make this a 4. Let's make this, let's use easier numbers, sorry. Let's make that a 3. That's not to scale. Let's make that a 2, and let's make this guy a 12, an 8. All right, so if you take the first two, right, are these two shapes similar? These two right here. Okay. Are these two shapes similar? Well, same shape, right? The different sizes. Are the sides proportional? So look at the relationship between these two sides. Right, so you know that scale factor here is times 2 times 2 to make it bigger, or if you wanted to make it smaller, it was times a half, times a half, right? So all the sides were multiplied by the same scale factor. Likewise, let's use, it doesn't matter which one, let's use these two here. 6 and 12, and again, same scale factor, I just happened to choose that one, times 2, 4 to 8 is times 2, so all the sides were multiplied by the same scale factor, whether you're going up or down. If it's up, it's obviously times 2, if it's down, it's times a half. That's the difference between congruency and similarity. Okay, that it? Well, let's see what your lesson says. So if you understand that, you should be okay. Now, the lesson today was about triangles, right? One second, please. But in the triangle, okay, if, oops, clear page, there we go. In a triangle, what they were asked today is, can you justify that using two angles in a triangle was enough to prove that two triangles were similar? That was your question today. Well, let's look at this first triangle. Let's call that, and then say triangle A has one angle that's 53 and the other one that's 71. Just to be different, I'm going to tilt this triangle a little bit, right? And then I'll call this 53 and this 71. Well, they share two angles. Well, we know that the third angle has to be the same, because if you subtract 180 minus 53 minus 71, it's going to give it the third angle. 180 minus 53 minus 71. And our third angle is 56 here and a 56. It has to be, right? Because both triangles, the sum of the angles in the triangle is 181. So are these two triangles similar? Well, they are similar because all angles are congruent, and if all angles are congruent in a triangle, that's enough to prove similar. They might not be the same size, okay? They might not be the same size, which is fine. So one triangle might be, I don't know, let me draw that again. One triangle might be this size, and the other triangle might be this size. All the angles, right, this and this are congruent, corresponding are congruent. These two are congruent, and these are congruent. Which means that it's, however these were scaled up or down, I'm making these numbers up. So if that was a 4 and this was a 12, guess what? That scale factor of times 3 was applied to the other side. So if this was 5, this is 15. If this was 6, guess what? This is 18. All sides were multiplied by the same scale factor. So all the angles are going to be congruent, so the angle values are going, but the sides are going to be proportional. Okay. Meaning the same scale factor we use to either make a bigger version of it or a smaller version of it. Number 4. No idea what that means. What is that says? Draw two equilateral triangles. So go back and understand. An equilateral triangle means that all angles are the same. There's only one possibility, so not congruent. So an equilateral triangle, and let me get a triangle here. It's a triangle where all the angles are the same. So take 180 and you divide it by 3 to make all the angles the same. This is the only possibility. So this is an equilateral triangle. So draw an equilateral triangle where it's two equilateral triangles where they're not congruent. Meaning, if this is, I'm making this up, 5, 5, 5. Draw another one where it's 60, 60, 60, and then let's make this 6 just for the heck of it. This is 6, this is 6, and then this one is 3, 3, 3. Are they similar? Yes, they are. Are they congruent to each other? They're not. Okay, so they were all. We use a scale factor of 2 or a half, depending on which way you're going. Okay. Now, can you draw two triangles, okay, that are equilateral but not similar? That's kind of impossible. So if you drew here's my equilateral triangle, right? Can I somehow draw another equilateral triangle where everything is 6? So let's make, again, let's make 6, 6, 6 here. Can I make another equilateral triangle where the angles are 60, this is 60 degrees, this is 60. Can I make a triangle that's not similar, meaning there's 60, 60, 60, but maybe here is 3, and this is 3, and this is 4, 9, and you just can't, right? Because if you change the length here, it's going to change the angle. So this is not possible to do. I can't think of a way of doing that. Do you think two equilateral triangles will always, sometimes, or never similar? Will always be or never similar? In an equilateral triangle, first of all, right? What do we know about two equilateral triangles? So here's one, and let me duplicate that. Duplicate. So let me make that a different size. In order to be similar, their angles are going to be congruent and their sides are going to be proportional, right? Or they're going to be the same scale factor is going to be used. And if that's true, I mean, with two equilateral triangles, the case here is always going to be they're always going to be similar. There's no way of me taking this triangle and enlarge it or dilate it and change the length of one of the sides. It's just not possible. If it's similar, right? So no matter what this number is, let's say 10, 10, 10, there's no way of making this 5, and all of a sudden this is 4. It's just not possible, right? If I'm using the same scale factor. And the angles will always be congruent. So the answer to this, it will always be similar. Okay. In this figure, triangle BC, the segment BC is parallel to DE. Okay, got that. How do you know the triangle ABC is similar to triangle ADE? Right, so let's trick to this one is, for me at least, is to separate this. So here's my little triangle, ADE, and then the big triangle, same triangle, right? ABC. How do I know they are similar? So what is this? A, this is B, this is C. Now, and we know that this is parallel, and here comes transversals, right? This is transversal, so somehow we have to prove. So if you think about, well, maybe I know that angle A here, this angle, they both have the same vertex, so these two are the same. Remember, one more angle. I need to prove that one more angle in each triangle is the same, and we're home free. So let's look at the original. So if you extend this line here, there's a line, right? This parallel line here, this parallel line, right? Go back to our transversals not too long ago. Right, so let me move this fellow over here. Move this fellow over here. So here's my transversal, and it's cut. So here are my two parallel lines cut by this transversal. So what does that tell us right off the bat? That we know that this angle here and this angle are exactly the same. So this angle is called D, this angle, and this angle are the same. They're corresponding angles, right? So they are the same. So is that enough? In a triangle, it is. Because, and I'm making this up, but if this was 45, I don't know. This was 50 degrees, this is 50 degrees. And now that we proved that this is the same, if this was, I don't know, what does that look like? A little bit more than 90, so if it was 92, this is 92. So notice that this third angle is going to have the same value because both of these I'm going to subtract 50 and 92 from 180. So how do you know the triangle ABC is similar? Because angle A on both, or I don't know, angle A, the first angle A is both, is the same value for both triangles. And angle D and angle B are also the same value. And in the triangle, once I know two of the angles are the same, I know the third angle is also the same, which means this is a similar triangle. Okay, so we don't have to go too much about that. All right, which of this following best describes the triangle shown? Okay, all right, so we know these two angles are the same, so we have one angle that's the same, check. They have a symbol over here. See that there's two lines here, so they're saying they're equal, so I know if that's 30, this guy's 30. And what else? And obviously if that's 90, that's 30, they share also the 60. So this is two exact triangles. I mean, if you were to, here's a line of reflection, and reflect this to the other side, one would fit right on top of the other. So what are we talking about here? They're congruent, number one. They are congruent. Everything is exactly the same, the sides and the angles. They're congruent, and they are similar. So you're going to say, why are they similar? They weren't scaled. Well, they were. Think about this. How does this 16 become the 16 times 1? So that means that whatever this side to become this side times 1. How this side become that side times 1. So what was the scale factor? 1. Remember, you can dilate it. If it's greater than 1, it's going to be greater, right? You can dilate with a scale factor equal to 1, which means the same. It's going to be the same. And if it was less than 1, it would be, the shape would have been smaller. So congruent but not similar? No, they're congruent and similar. That's similar but not congruent. Well, it is similar and it is also congruent. So that's B's not it. It's both similar and congruent, and there's your winner. Triangle A. So let's actually draw this. Right? So here's a triangle. And at a 90-degree angle, okay? Let me try a little better. And so that's 90 degrees. You're telling me that this is 33. Triangle, so this is triangle A. Triangle B has two angles. Right, so it's also a 90-degree angle. 90-degree angle. It has to be this one. And in triangle B, this is, let's call this 57. Well, are these two triangles similar? Well, I don't know yet, but I can find out once I find this missing angle in triangle A. Right, so once I find this guy right here, which I don't know, and once I find this guy right here, which I don't know. So let's do triangle A. In triangle A, I'm going to do 180. I take away that 90, and I'm going to take that 33. Let's see what I have left over. So 180 minus 90 minus 33 equals, look at that, 57. So on triangle B, I'm going to do 180 minus 57 minus 90. And guess what I'm going to get? I'm going to get 33, which is going to be this angle right here. So are they similar? Well, now that we know all three angles are congruent, are these two similar? Yes, they are. I don't know what size the dimensions are. I don't know what the length of the sides are, but I know it. But those three angles are the same, which means those two, the triangles, it could have been even this little triangle right here, where that's 90, this is 33, and this is 57. So are they similar? That's the question. Yes, they are. Are the sides congruent? That I don't know because I wasn't given the information. I don't know what the measurements were. But It could have been congruent if it was the same, or it could have been, hey, proportional. So let's say this was 10, this is 5, right? Everything was scale factor of 2 or a half, right? Spiral review. A figure is translated 3 units to the right and then dilated by scale factor of 3. Determine whether the pre-image and determine whether the pre-image and image are congruent, similar, or neither. Okay, so let's make this simple. So here is a rectangle. Let's say this is 2 and this is 4. It's super easy. And we move this guy 3 units to the right. So let's go. And then, so we're moving this 1, 2, 3. And if I move it this way, it's going to be right about here, right? So the rectangle moved 3 units to the right. Move 3 units to the right. Oh my god. Move 3 units to the right, right? And then they took that and made it, they use a scale factor of 3. What does that mean? Multiply 2 times 3, multiply the 4 times 3. So now, after a dilation, it's going to be, change colors. This side here, our height is going to be 6, and our length of here is going to be 8. So, what do we know about these two rectangles? So, I'm sorry, what? I'm just going to have to make you imagine it. So here's my original rectangle. This is 3 and this is 4. We move it to the right, and just assume I moved it to the right. Okay, I don't want to do it on top of each other. Move it to the right. Same rectangle. So still 3 and 4. And then from there, I'm going to use a scale factor of 3. So this 3 is going to be times 3, and this 4, I'm going to be multiplied by 3. We are obviously going to have a bigger rectangle. So times 4 makes this guy, our length here, it's not going to be 4 anymore. Times 3 is 12. And going up and down, it's going to be 9. So this is the original, and this is finally the post image. So the question is, are they congruent? Well, if they're congruent, the angles are congruent. This angle, this angle, this angle, this angle is 9 degrees, 9 degrees. So is this, so is this, so is this, so is this. But are their dimensions congruent? Is this 3 the same as 9? No, it's not. So side length, not congruent. Are the angles congruent? Well, all 4 angles are congruent. And then what about, is it similar? Well, yes, it is similar. It is similar. Okay. Because although it's not the same size, it's similar. It's the same shape. And it's, although different size, what do we talk about? The side lengths, they were multiplied by the same scale factor. And the ratio of 2 sides here and their corresponding sides are equal. Done. Okay. So, yeah, that's literally, this is our, you're okay with that? Okay, good. So again, congruent means same measurements on the side length, or same angles, depending on what you're asking. And then similar, you can be similar, right? If you have the same shape and your side dimensions were either dilated up or down by the same scale factor.